Okay, example 4, it says solve the equation 3 over x minus 3 equals x over x minus 3 minus x over 4. Now, what we did on Friday, if you recall, we had a single fraction equals a single fraction, or a fraction equals a number. We did a lot of cross multiplying because we only had two terms. Fraction on the left equals fraction on the right. So, today, you'll notice that we have term 1, term 2, and term 3. Terms are separated by pluses, minuses, and equals. So something equals something minus something. There's three terms there. So it's not set up proportionally, so we can't do cross multiplying on this problem. Okay? The other strategy that can be used to solve a rational equation would be to find the least common denominator of all the fractions present in the problem. So the denominators in this problem, if I'm looking at these denominators, are x minus 3 and 4. Okay? You don't have to write x minus 3 twice if you got the same denominator happening several times. All right, so x minus 3 is the same as x minus 3. Write it down once and then 4. And if I were to factor them, I can't factor x minus 3. 4 is 2 times 2, but that doesn't really help me because there's no 2's in the other one. So the least common denominator of this, least common multiple of these denominators, is 4 times x minus 3. And what I'm going to do with that information is if I rewrite the problem, and so basically this is the problem in the book. As I copy it on my paper, I'm going to do this. I'm going to write 3 over x minus 3. I'm going to leave a gap, put an equal sign. Then I can put my next fraction, x over x minus 3, leave a gap, put a minus sign. And then put my last fraction, x over 4, and then I got some space behind it. Okay, what I'm going to do with the gap in each of these scenarios is I'm going to multiply each term, the blue highlighted term, the yellow highlighted term, the green highlighted term. I'm going to multiply all three terms times the least common multiple of the denominator. So I'm going to multiply times 4 times x minus 3, multiply by 4 times x minus 3, and multiply times 4 times x minus 3. Just like that. And notice the positioning of 4 times x minus 3. I'm positioning it up on the top of each of these fractions. This is up top, up top, up top. And what I want to do as I multiply is a top object that matches a bottom object can cancel. So the x minus 3's cancel. Always cancel first and multiply the leftovers. So the leftovers here are 4 times 3 makes 12. I got a top x minus 3 and a bottom x minus 3. Cancel, cancel. I'm left with 4 times x. What's left on top is 4 and x, so 4x. And then here I've got x over 4 times 4 times x minus 3. The 4 matches the 4, they cancel. Leaving with minus x times x minus 3. Okay. And the end effect of all that is that all the fractions disappear and you're left with an easier problem. Okay. And now, at this point, I want to simplify as much as possible, recognize the distributive property situation, binomial times monomial, so multiply this times both things. So 12 equals 4x, and then minus x times x is minus x squared. Minus x times minus 3 is positive 3x. Okay, be careful that minus makes a plus when you're distributing. The minus is attached, it's multiplied by a negative. 2 negatives make a positive. And finally, 3x and 4x are like terms on the right-hand side, so I can combine them together to get 12 equals negative x squared plus 7x. That's the simplest form of the equation before I start trying to solve it. Okay, so get the equation simplified as much as possible, combine your like terms, get the left and right hand side as simple as possible. Then we're going to move everything to one side. It is quadratic. When I see quadratic, I want everything equals 0. And x squared I like to be positive, so I'm going to move x squared and 7x to the left. So x squared is going to become positive on the left. 7x to become negative on the left, plus 12 equals 0. And then finally, quadratic, I'm looking at possibly factoring it if I can. If I can't, I can use the quadratic formula. In this case, 1x squared is an easy factoring technique. Two numbers multiply to make positive 12 that also had to make negative 7 or negative 3 and negative 4. So I get x minus 3 times x minus 4 is equal to 0. Remember our factoring of quadratic trinomials. Simply need a pair of numbers that do both the product and the sum of the numbers here and here. Once I get factored form, either factor 1 equals 0 or factor 2 equals 0. Then I simply solve those by moving the 3 and the 4 over to the other side, change the sign. So when I move the 3 over, negative 3 moves over, becomes positive 3. Move the 4 over, negative 4 moves over, becomes positive 4. And that list, that's my answers to the problem. Now, the last thing I got to do for a rational equation, anytime you see equations that have x's in the denominators, is you're not allowed to have 0 in the denominator, so you have to look where the denominator is x. So this denominator has an x in it, this is the exact same denominator, and this doesn't have an x in it, right? So first of all, 4 cannot equal 0, right? So that's irrelevant. But x minus 3 is not allowed to equal 0 for this problem. Because if x minus 3 equals 0, we're dividing 3 by 0, we're dividing x by 0. So if x minus 3 is not allowed to equal 0, that means x is not allowed to equal 3. Does x equal 3? Sure does, right? So we worked through the problem. We did this get rid of fractions deal. And by getting rid of fractions, we got rid of that whole division by 0 thing with the 3. And we worked through the problem. We got 3 as an answer. That is called an extraneous root. That has other names that other books might use. I've seen erroneous roots before also, but extraneous roots, the terminology this book wants to use for that specific situation. An extraneous root is a root that is found to be an answer that's not allowed to be an answer due to some mathematical reason. So when you get an extraneous root, you see this is not legal, but we got it anyway, we throw it out. So we're going to scribble the 3 out. So x equals 4 is the only solution to this problem. In the event that every single answer you get is extraneous, then you're going to get an empty set answer. Empty set being the open circle with a slash through it. Okay, so that can happen. In fact, it might happen on your homework. So I want to say there was one in your homework that had an empty set answer. So be prepared for that possibility. But again, that's how you handle an extraneous root.